Workshop 3. This workshop is intended for your assignment 3. So the workshop is due on week 13 Monday instead of week 13 Friday, because this assignment has two parts. One is the report, another one is online short interview we call personal online check with a tutor. So all of them has to happen by week 13. So that's why you put the due date of the report submission on week 13 Monday, so that the rest of the 4 days we can use for interviewing you guys. Okay, so let's give a brief of assignment 3 before I actually go to the details of assignment 3. And then following that, I will discuss the marking guideline and details of the assignment and possible solution hint for assignment, okay, in coming videos. So first of all, I'll give you a brief overview. First thing is assignment 3 is 50%, okay, so it's big weight. So I have previously seen student got good grades in assignment 1 and 2 because they are programming unit, but put less important in assignment 3, which is worth of 50%, and when they did not get expected mark, then their whole grade overall got um, reduced overall. Okay, so careful about that, and be pay attention to this assignment as well, because this is a complete different assignment than assignment 1 and 2. Okay, so what this assignment is about. So this assignment actually covers the theories we have discussed in. All right, so from the theory, we have covered in the theory, if you can remember, we have covered cloud mechanisms, we have covered cloud architectures, we have covered cloud models. So those chapters will be important for this assignment. So assignment 3, in assignment 3 you have two parts. One is part A, one is part B, 25% and 25%. Okay, so in the first 25%, which is part A, we are proposed with cloud architecture and mechanism problems. Okay, so we are given a scenario. The scenario tells about a TAIF, which currently going through COVID situation and trying to estimate, okay, trying to estimate how many number of enrollment of the student will be in 2022. So it can vary, and that's why it's planning for setting up some computer laboratory, programming laboratory. Okay, so in the current setup, we can see, so there are all the configurations are provided. So how many computers they have? So Pioneer Cafe, they have 3 campuses. One is Brisbane, Sydney, Melbourne, and each campus has a single super computer known as server A, server B, server C. Okay, now all the 3 server has equal computing power. Now there are some threshold given. Okay, so you may be not familiar about the threshold, but if you look back to the theory, to the book, if you look back to the book, so this is the book we are reading, the textbook, in the chapter 11, fundamental cloud architecture. When you go to the architecture, you'll see there are mention of workload threshold. Okay, so workload threshold is a threshold that a a machine or a resource can take maximum. Okay, for example, you have a laptop that can run 5 programs at a single time together simultaneously. Okay, so that's sort of like a workload threshold of your laptop or your computer. So similarly, because these are physical server, so they have their own workload threshold. So because this is cloud and we are trying to, like the Pioneer Cafe is going to create some cloud system, looking for some cloud system, whether it could be on premise, it could be their own cloud, private cloud, it could be commercial cloud from AWS or Microsoft Azure or IBM. Okay, whatever that is, first of all, you have to consider what resource Pioneer Cafe already have. So they have 3 servers, and each server can host maximum of 6 virtual server. So if you go through the theories, you know that like cloud system actually works on virtual server. They don't work with physical server. Cloud provider use the physical server to create virtual servers, and in the virtual server, the cloud provider create cloud service with different apps, and those apps or the virtual server, they are then shared with the cloud users. Okay, so in this scenario, we have a single physical server. A single physical server can host 7 virtual machine, and currently it's hosting 6 virtual machines. So there is a maximum capacity and a current capacity allocated is mentioned. Okay, so maximum capacity is 7, then threshold for virtual servers. Now if you have virtual servers, you will run the virtual server for hosting apps or cloud service. Now let's have a look how many maximum cloud service you can host in each virtual server. So the workload threshold for virtual server is 6. It means each virtual server can host maximum of 6 service. So which means maximum 7 into 6, total 42 cloud service can be hosted for each server. Okay, of each. Okay, so don't forget about this is for a single physical server. This is for a single virtual machine. So 7 into 6 would be 42. So it means a single virtual server, a single physical server can host 7 VM, and each VM can host maximum 6 service. So therefore 42 service maximum. And currently they have 6 into 5, which means 30 service currently running or currently hosted. So the current workload allocated or the current request or number allocated is 30. The maximum is 42. Okay, from these 2 points we can see that. All right. Now the cloud service instance. Okay, so the cloud service of the cloud app can handle a single student request at a time. All right. So therefore, as we told, so 6 into 5, 30 is the current allocated um, workload. So therefore, we have 30 enrollment in campus. So for 30 students, we are using 6 virtual servers and 5 cloud instance at this moment on each virtual server. Therefore, 6 into 5 equals to 30. All right. So let me just clarify it, so it will probably help you a bit. So let's say I have one server, so I'll just show one. So this is say in Brisbane, Brisbane server. Okay, so it can host maximum of 7. 1, 2, 3, 4, 5, 6, then 7. Okay, so it can host 7 virtual machines. Okay, so virtual machine, virtual machine, virtual machine, virtual machine, virtual machine, virtual machine. Okay, this one is left. Okay, currently we have 6 virtual machine hosted on each server. You can see from here 6 virtual server now hosted, and each virtual machine can host 6 cloud service instance. So I'm not showing everything, I will just show one, 2, 3, 4, 5, 6. Okay, and the rest I'll just give dot dot dot. Okay, because they will be the same. So cloud service instance, say for example this is a Blackboard or my enrollment app. Okay, so 1, 2, 3, 4, 5, 6. Okay, that's the capacity, and currently each virtual server is hosting 5 among 6. So basically let's say this one is still empty, one of them is still empty. Okay, so with that we can accommodate 30 students request. All right, 30 student request. So because each student can be handled by a single service at a time. Okay, so here is 5 instance currently, and here is 6 instance currently, so therefore 6 into 5. Okay, so number of 6 equals to number of currently working virtual machine, currently using virtual machine, because I told like one of them is still not working, one of them is left. Okay, not utilized currently. And then from the virtual machine 5, each virtual machine can host 5, though the maximum capacity is 6, and each virtual machine is hosting 5, and each cloud service can take request from one student, so therefore it will be 30. So this is the current scenario, this is the current workload allocation or current utilization. Okay, now what is the maximum utilization? So each physical server can do for each, so this is for each physical server, each physical sorry about my writing, but it's for each physical server. Now what is the maximum? This is the allocated. What is the maximum one? So we have maximum, the physical server can take 7 virtual machine. Each virtual machine can take maximum 6 virtual cloud service, and each cloud service maximum can take 1 student, so therefore it will be 42. Okay, so this is the max I can go in each server. Okay, it's important to find it out, I am explaining why. Okay, so now let's have a look at, we are done. Now let's have a look at part A. Okay, so in the part A, remember that you can use commercial cloud provider and a resource from other 2 campuses. It's up to you how you design it. So you should look for an cost optimum scenario. You know that first you should look for first you should look for your on-premise. Like if Brisbane campus you cannot do this, you can look it from your Sydney and Melbourne campus. But if you think that is not possible, then you can look for commercial cloud provider like AWS, Azure, IBM Cloud, all those things. Okay, now let's see system 1. Okay, So a given scenario is given. So for the scenario, you have to propose a solution. Okay, and system 2. So let's first see what the scenario is. The scenario is the number of enrollment of Brisbane campus will be increased to 50. Okay, 50. So what is the problem? The problem is this. Brisbane campus can maximum take up to 42 students. It cannot take up to 50. Okay. So what now you can do? Okay, so the number of student enrollment is coming more and more. So what you should do? It's about, and remember, it's about number of students, number of enrollments. So it's about the number of requests coming in. Okay, so focus on these things. Sometimes student pick up incorrect architecture. Okay, you lose mark if you pick up incorrect architecture. You have to understand what the issue is. Is it a workload issue or is it a scaling issue? Okay, from the description what we can see that it is actually, so our enrollment will be 50. Okay, so it's a most more, from the description we can see that it's actually about a number of requests coming in. Okay, so the number of requests coming in, our Brisbane server cannot be able to do that. The maximum capacity is 42, but we'll have 50 enrollment. So what you can do, you cannot just say student that okay, go back, I cannot take the eight more students. Okay, you can just keep 42 and then leave the other 8. You cannot do that. You have to design your lab in a way, you have to design your cloud system in a way so that you can enroll all 50 students. Okay, so now you have to propose a solution to do this, how you can expand the capacity of Brisbane campus so that it can accommodate 50 students. And again, I'm telling it's about number of requests coming in. Okay, so it's, you should be able to distinguish between the workload issue and scaling issue. In this case, it's a scaling issue. Okay, so it's actually scaling. The problem is about number of requests coming in. So the number of requests increased. It's not telling that, okay, you have to remember workload architecture always try to balance the workload. Okay, but here it's not about balance the workload. Does the problem say anywhere about balancing workload? No. It's saying that you don't have the capacity for the number of students. So it's about increased number. That's why most likely it's a scaling problem. Okay, so put focus on this and try to identify. I cannot give you a definite solution, definite answer, because that would be part of your solution, that will be part of your proposal, but I'm just giving you some hints and pointers. Okay, this description does not say anything about balancing workload. This description say that you have increased number of students, you have to give them access. Okay, so you need to increase the capacity of your Brisbane campus server. Okay, okay, so now how you can do that? So I will say erase, sorry, let's say I will create a new one. So I have my physical server with my physical server. This is the Brisbane server, server A, server A. Current threshold is 42, but incoming request threshold will be 50. Okay, so now what you can do now, as mentioned here, you can take help from the Sydney and Melbourne campus server, or you can use commercial server, but you should do that optimal way. So you first look at Sydney Melbourne campus because you already have that resource, and then you should look at commercial server if your problem is not solved. Okay, so now let's see what system 1 is taking. Design a cloud system. System 1 is talking about this to handle this scaling issue. Remember, it's already saying, it's already giving you enough hints, because I have seen student picking up or student using incorrect architecture to propose a solution. First of all, check what this issue is. It's a workload issue or scaling issue. It's clearly saying that it's a scaling issue, and you have to handle it dynamically. For Brisbane campus, use appropriate cloud computing architectures. You can use multiple architecture. You can use single architecture. The design should include a detailed diagram including all crucial components of the architecture. Critically discuss how the system would work. Okay. So usually if you use multiple diagram, that's fine as well, so that you can elaborately see. But if you can include everything in a big picture, big diagram, that's fine as well. So a big picture of your new architecture, you proposed architecture, plus how that architecture will solve the issue. Okay, so that's system 1. And system 2 is also the same thing. The goal is to admit 50 students. So you need to increase capacity of your Brisbane campus server, server A. However, when you do in system 2, you have to follow a different architecture or a different mechanisms. You cannot just use the same types of architecture. For example, if you are using scaling, if you are using horizontal scaling in system 1, you should use vertical scaling in system 2. If you're using dynamic relocation in system 1, you should use horizontal scaling. Okay, so a different scaling. So that's what is called as variant. Use a variant of the cloud architecture or a different mechanisms. Okay, or a different architecture or a different cloud architecture altogether. Okay, so the architecture you proposed cannot be the same in the two systems. They has to be different. If they are same, you will lose mark. Okay, so by now you probably got idea about the problem. So the problem is actually a scaling problem. So that's why you have to follow a scaling architecture. So if you look at chapter 11, there are some scaling architectures, for example, dynamic scalability, then resource capacity. Okay, there are a few. So you have to pick up, it's your job to pick up which one suits the more. You may need to combine two architectures. Okay, so elastic resource, then workload, or whatever, like whatever you think that should be possible, but it has to be relevant. It has to uh, go with how, what the problem is asking you to do. You cannot just use a irrelevant architecture. Okay, so there are other architectures as well. For example, there are advanced cloud architecture. So you have to look through these architectures chapters: hypervisor clustering, load balanced, virtual server, non-disruptive service relocation. For example, you can combine this non-disruptive when you are relocating. For example, from fundamental, you propose this dynamic scalability. So one of the dynamic scalability is dynamic relocation. So that's a variant. So as I was talking, one in system 1 you can do dynamic horizontal scaling, in system 2 you can do dynamic relocation. For example, this is the variant. So you have to use different variant or different cloud architecture. You cannot use the same cloud architecture for both system 1 and 2. So when you're doing dynamic relocation, for example, you can use this non-disruptive service relocation. Okay, so you can use non-disruptive so that it does not disrupt when you relocating. So in that way you can merge or combine two different architecture together. Okay, so think about it, go through these architectures and find out what is the best actually way to which combination or which architecture should be the best way to actually solve this fast problem. Okay, so if I look back now, so now what you can do is, for example, if I do a dynamic scaling, a horizontal scaling. So in the horizontal scaling, what we do is we add more resource. Okay. So when we are adding more resource, it means that we actually can increase the number of how many cloud service instance we can take. All right. So if I just look at the cloud computing architecture, dynamic fundamental architecture, then dynamic scalability, for example. Okay, so when this increased, you can see like how that they work. So you should know this by now. There are class lecture recording are put into your Blackboard site, so have a look. So when there are more requests coming in, usually because they are out of the threshold, so the automated scaling listener will reject them. But after that, they will adjust it. For example, you can do resource replication. Okay, so resource replication is sort of like a horizontal scaling of the physical server or virtual machine. Okay, so you have say 1, 2, 3, 4, 5, 6, 7 virtual machines. So what you can do is you can create resource replication of the virtual machine. So resource replication will add, say for example, one more virtual machine or two more virtual machine with for you. Okay, so say that your computer has your computer your physical server, it has 1, 2, 3, 4, 5, 6, 7. Okay, the 7 one. Okay, now for the 50, say you need how much you need. You are short of 8. So short of 8 means you would need, and each virtual server can take how many of them? Hosting, each virtual server hosting 5 instance. Okay, so you need 2 virtual servers. You need to add 2 virtual server with it. Okay, so now you want to add 2 virtual server, say 1, 2. It doesn't matter how you add it. You can do it by resource replication, or you can do it by horizontal scaling. In many way it can be achieved. Okay, look through the theory classes. But the main concern is not that. So you're adding, it will solve the issue. That's not the problem. The problem is whether your computer has the capacity to run these 2 additional server. No, no, it cannot run it. So to be able to, so these are the critical thinking I want to see, or we want to see when you're proposing this. Okay, so you cannot just shoot, like you cannot just put, because it's physical server, it's limited capacity and it's already mentioned 7. You cannot make it 9. Okay, you are going to make it 9 from 7. So to make it 9, you have to give it more capacity, right? You have to give the physical server more capacity. So how you can do that? So to do that, you need to add more memory, more CPU, more storage, for example. You first have to upgrade your physical machine, right? So for example, you want to, it's same thing like you want to play a high configuration game, so you have to upgrade it first. It doesn't matter what virtual machine you have created for that game. Your game has to run from in that physical machine, right? So your computer does not have the capacity. It has the capacity of 7. Now you want to make it 9. So you first have to upgrade your physical machine. So you can do it by resource pooling, we call. So we have a resource, let's say I just call resource pooling. Okay, so you want to do with resource pooling. So we have a resource pooling architecture for that. Now, if you want to use it, use it. But I'm trying to give you hints about what things you have to consider. Now, once you have added these things, uh, let me get, you have actually added more capacity. Now your computer is good to go. Now instead of 7, the capacity is now 9. Now your scaling listener can create these new instances by resource replication, right? So this thing is the thing you have added, the RAM or memory or CPU, the things you have added. This is actually one type of vertical scaling. So what you have done is vertical scaling. So see, like it's actually not that straightforward. It's actually quite complex. But if you understand the theory, it will be very easy for you. Okay, so what you have done, you have just added memory and storage with your physical server. You have done actually vertical scaling because you have upgraded the capacity, and that led you to create this new instance, additional instance of your new virtual machine. Okay, so this one new, this one is new, and this one is new. Okay, so you have added these two things, so you have increased the number. So this is in a sense a horizontal scaling. Okay, so once you do that, then you should be able to, now you have 9 virtual server. Now your 9 virtual server should be able to, so you have 9, and each virtual server can have a maximum of 6. Okay, so you can have maximum 54. You can have maximum 54 students coming in Brisbane. Okay, so that's one of the solution. You just added new resources. Okay, now if you are trying to use your Sydney or Melbourne campus, then you can do similar thing like this. So for example, I have my physical server A. These are my physical server B, for example. Okay, physical server B from Sydney. This is B, this is A from Brisbane. So I currently have 1, 2, 3, 4, 5, 6, 7. 7 virtual machine. I need 2 more virtual machine. Okay, to host my remaining students. Okay, so you borrow that 2 virtual machine from Sydney, right? So you borrow that 2 virtual machine from Sydney campus. So you can borrow them, and those virtual machine can be added those student coming student, they can be navigated to that Sydney campus. Okay, instead of adding it, because if you want to add here in physical server A, you have to increase the capacity of physical server A. Okay, so when you, okay, you, for example, you can use a bursting architecture here. So when you have 6 into 7 equals to 42, whenever you have 43 number student coming in, they will automatically navigate to physical server B. Okay, those the virtual machine in physical server B. Okay, so that can be done using a cloud bursting architecture. Okay, so the problem represented, it can be resolved by different ways. Okay, all right. So here, how you look at this problem, how you look at this part A. Okay, whatever the goal is the same for system 1 and 2, you just have to use two different architectures or different variant of the architectures. Okay, and remember, you have to discuss critically how that resolve the issue, the thing you proposed, how it will resolve that. All right. So that's, I hope that makes sense about system, the part A. In the next video, we'll talk about part B. Okay, so part B.